Um, Good evening, everyone. Today we are going to discuss about deletion of a node. In the last class, we have discussed how to insert nodes in a linked list, like in various positions, the starting, in the middle, and at the end. In the same manner, we will be discussing how to delete a node, deletion of a node in the list. Um, the advantage of linked list is insertion and deletion of these nodes as and when and where and when we want. So that is the reason, that is the main advantage of linked. So this insertion and deletion are the very important operations on your linked list. How to delete a node in linked list? See, this is what a linked list is. This is a head pointer, which is pointing to the first node of the linked list, and this is the current node which you want to delete. Now, how will you delete this node? So before deletion of the node, you have to manipulate the links. Links in the sense the fields, the link fields which are present in each node, or not each node. The previous node has to be changed so that no, the next linked list goes on properly. The list continues properly without any errors. So to delete the node current, we need to modify the link between current and its previous node, and also the link between current and its successor. If I'm deleting this node, so there will be a change in the link here, as well as mainly the link here, and also uh, yes, the link here has to be changed, shifted here, because this address will be lost, and this is the node which I am deleting. So there will be a change in the previous node and as well as its successor. So what's the algorithm for this? See, let both current and previous node variables set to be head, traverse the list and search the node to be deleted. So first we have to go through the list and we have to decide or find out which node is the one which you have to delete. So let current point to the node to be deleted. So we are saying that this current is nothing but the node which you want to delete. Let's point it out like that. Let's put it. I think take an example like this. Okay, and previous B is previous node. So current is the node which you want to delete, and previous is the node which is the predecessor of this node. The node which you want to delete. So what happens? You have to modify the links like this. So modify the link field of the previous so that it skips the current and points to the next. Yes, because if you are deleting this node, what should happen? This link, the node, the link field in this node should point to this node. Simple. That's what. So you're deleting this node. So this has to be removed. So there is no link. So this link has to be changed such that this points to this node. That is what we are doing here. See, previous link is pointing to the current link. So what is this current link? Current link is nothing but the link in this current node. So what is the link in this current node actually? This is the link that is pointing to this node. So my previous node has to point out to this node. So what I am doing? So to delete this node, the link which is present in this field is deleted because I am deleting this node. This link corresponds to this node. So delete this one and put the link which is in this current node because it is pointing to the next node successor. So you put it here. So automatically the this node will be deleted and this previous node will be pointing to the next node. So that is what we are doing here. So free the memory allocated to the node current. Stop. So see here. See, so what I'm saying is, what this link field will contain, this will contain the link for this current node. Yes. So this is the node which I want to delete. So what I will do, I have to do, this node has to point to this node. So how this node is going to point to this node, then it will have the uh, address of this node, I mean link of this node, then automatically this will point to this node. So where the link of this node is, it is here. It is here. So I am taking this and putting it here. That's it. So the link which is here, I mean in this current node, which is pointing to the next node, is moved to the previous link. So it is moved to here. It is moved here. So automatically next in the next when you run the program, this will contain the link to this node, and this node will be deleted. I mean the memory allocated for this node will be freed. So this is what, how you delete a node in the linked list. So see here, that is what we are doing here. So just you are taking two uh, headings like current and previous to avoid confusion. Both are set right. You traverse the list and search the node which has to be deleted. And you want to, when you find out the node which you want to delete, you will store it in the current node. And the one which success previous predecessor to it, will store it as previous. Now what you will do, you will store the link which is present in the current node. I mean the node which is to be deleted, you will store it in the previous link. The previous link will contain actually the node of the node to the current node, the one which you have to delete. So no need of that node link. So you are replacing the link field in the previous node to current link so that it points to the next node and free the memory allocated for the node current. This is how your deletion is, I mean, deletion happens. So the node to be deleted can be at any position. It could be first, middle, or last. So how to delete the nodes? I mean, at the first node, middle node. Okay, that is what we will see here. So how to delete the first node? So actually, the first node is the header node. So deleting the first node is also referred to as deleting a header node. So if the node at first node position is to be deleted, then we need to modify the pointer pointing to the first node, also called as head pointer, say head. So when you are deleting the first node, which is nothing but the header node, you have to change, the main thing you have to change here is the head pointer. So we have already discussed. Always we have a pointer stored separately or a pointer called head, which points to the first node of the linked list, because we don't have any other provision to know where the actual linked list starts from. So always we have a pointer called head pointer. So which is also called in simple terms head, which will point to the first node of the um, linked list. And that first node is called the header. And the pointer is different and header node is different. So deleting the first node, you're deleting the first node, it is also called referred to as deleting the header node. So how it is deleted? So here, see, deletion of the first node means the link manipulations here. So first, this is the head pointer, and this is the node which you want to delete, the current node, first node, header node. So you are setting it as current, and you have to change this head point, the pointer which is pointing the first node, header node, to this second node. So this will, because you delete this node, this will become the first node of this linked list. So you have to change the head to such that it points to this node of the point, a linked list. So that is what we are doing here. See. So what are the steps here? Set another pointer to the first node before modifying head, which is the pointer pointing to the first node. So what we are doing here, set head to point to the second node. So how this is done? So first we have to change this head to head, whatever head is there, we have to make it such that it points to this one, this second node actually, which becomes the first node now. So that is what we are doing here. So your current node is set to head. Okay, your current node is set to head, and this head is set to head link. Why? Because this actually the link part of this header node contains what? The address of this second node. Yes. So when I want to delete this node, I have to shift this address into this head node so that we won't lose the address of this node, and it points to the this node, which becomes the first node of our list. Actually, this is the second node, but with deleting this first node, now it is going to become the first node. So that is the reason the link part of this first node is stored in the head, actually, which used to store this address. We have to manipulate it to point to the second. So that is what we are doing here. So current is equal to head, and your head is containing the head link. Actually, this head link is the pointer to this. So now you will release the memory allocated for the first node, and so you have changed the link of the head. So the head pointer, head pointer is changed and not. So automatically you have changed the link. So this current can be deleted now. So that is what we are doing here. Delete nodes. These two statements will delete the first node, and the head will point to the second node, so that the second node becomes the first node. So that is the main role of these two nodes. Current node points to the head, and your head pointer is set to the link of the second. So head is equal to head link. So automatically you are setting the second node as first node by changing this head. So you can delete the current node, which is the header node. I hope it's clear. Next, deleting a middle node. So how to delete a middle node? So while deleting a middle node, what you will do? The same what you have done here. What you have done here. So you will set the previous link, the current link, and you delete the current one. Just uh, uh, change the links, shuffle the link. The previous link will be set to the current link. Already I have shown you why we have to store the current link, because the current node link will point to the successor. So when you are deleting the current node, I have to store the link which is pointing to the next node. So I am shuffling or shifting that link into the previous node's link. Obviously, the previous link will point to the successor by passing this current link. So and then I can delete the current. So this is how uh, the deletion of a node at the middle of the linked list will happen. Next. So we will see linked list variants in the next class. So this is all about your deletion of the node. I hope it's clear. So if you have any doubts, ping me in the group. Thank you.